Hello everyone and welcome to the third episode of our game tutorial series. So we were making this snake game and we finished after creating the head. So let's just run the program again just to see where we are at. And as you can see, we have a moving snake head. So the next step will be to create a fruit so that the snake can eat it and increase its tail length. So let's open a new tab, Control N, and save it, Control S, and call it food.py. Alright, let's import Pygame as usual. Alright, and let's create the class, capital F food, and let's define as usual our init function whenever we create our instance, and let's give it a self, and just as the snake head, let's give it a position X, position Y, a width, and a height. Alright, now let's create the class variables by typing in self.positionX equals position X. Same thing for the position Y, the width, and the height. Equals height. Alright, so as you can see, this is very similar to our snake head right here, and we don't need a movement variable because the food doesn't move, and we don't need a speed for the same reason. Alright, so now that we initialize our variables, let's create a draw function so that we can draw the food, and we'll need the self and the display variable. And let's do the same thing as usual, pygame.draw.rectangle, rect. Alright, and then here first we type in the display, then the color, and finally the position and coordinates, just like before. Now for the color, let's try and make it a red color. Alright, so in RGB we have first is the red, then the green, and then the blue. So this is the red, the green, and the blue. So if we set the green and the blue to be 0 and the red to be 255, that means that the food will be an intense, very red color. Now for the coordinates, which is this list right here as a third parameter, let's type in self.positionX, self.positionY, and then let's give it the width and height, so self.width and self.height, so that Pygame can draw the rectangle at this position and with this width and this height. Now that's all we need for now. So when you think of it, let's just try and run the program. When you think of it, we want to generate a fruit anywhere within the frame of our game display. Alright, and we want to detect collision so that whenever our snake head touches it, we generate another fruit. Okay, so we can come here and then simply import food, and then come here, create our food variable. So f equals food.food, and this creates a food object. And then here, as you can see, we need to pass in a position x, position y, a width, and a height. So for position x, let's try and make it and generate it randomly. So if you remember from previous episodes, you can import a random class right here. And for the x coordinate, we can say random dot rand int, so that it generates a random integer. Inside the parentheses, let's specify the range. So we want it from 0 all the way to the screen width, and from that we'll subtract the width of our food object, which is going to be 16, because of the drawing system, which, so instead of, because if let's say that this generates a 1280, so it's gonna print the top left corner here, and then it's gonna go ahead and draw the food, but as you can see, it's gonna be outside of the screen. So to fix that, we just shift by 16 to the left by subtracting 16 here. Let's do the same thing for the y. So let's put a comma, a y, and change the width to the height, and then let's type in 16 and 16 for the width and the height of our food object. Now what we can do is come here and say food dot draw and pass in the display. So now this will generate a food object at the beginning of the game. It says food has no attribute. Oh, it's f.draw. F.draw, because we're taking our object and using it and calling the function from our object. Alright, so let's save, Control S, and run it again. And as you can see, we have a food object. Now if we run the program again, it should generate it. Okay, it happened to be a little bit lower this time, and then it keeps on generating it randomly. Let's try again. As you can see, this time it generated here. So as you can see, it's pretty good at randomizing the spawn position. Now what we want to do now is detect collision, and whenever collision is detected, we want to spawn our food object at a different position. So let's do that. Alright, so there's a couple ways we can tackle this issue, but a simple way that I found of dealing with this is by going to our snakehead object and create a new function. Alright, define a function, and we'll call it get position. So this will return our snakehead position. Alright, so we'll just type in self, and that's it. It doesn't take anything, and it returns self dot position x comma self dot position y. So it returns two values. Right, let's save it and then go here. Let's also create the same thing here, call it get position, and let's just copy and paste the same function. Alright, now we can go back to our main .py, and then we can check for any types of collision. So what we can do is after we draw right here, we can say, for example, get this, let's create variables, call them, alright, let's create variables outside, right here. Call it s head, so snake head x, let's set it 0, s head y equals 0. So this is our head position x and head position y. Let's also create a fx equals 0. So this is the food x and the food y equals to 0. Now we can come here and say snake head y or x, comma, snake head y equals s head, which is our object, dot get underscore position. Right there. So s head dot get position right here will return a position x and a position y, and we're making it equal to a snake head x and a snake head y. Alright, so let's say that this is our x, right? X comma y coordinates, right? This is the x comma y for the head. So as we said, it's always the top left corner. So to detect a collision here, we have to check if this x is between this and this range. So let's just call this one x1, this one x2. Alright, so this is x1 and x2, and all we have to check is that this x is between x2 and x1. And we also have to check for the y, so the y has to be between y1 and y2 right there. Alright, so this is basic principle. So alright, so let's check. So we're gonna say if, let's start with the x. So we have to check for the x. So if this x is greater than x1, so this is gonna be our first condition. This is the x of the snake head, which is moving. Alright, so let's say s head x is greater, and x1 is simply fx. Alright, so if s head x is greater than fx and x is smaller than x2, so s head x smaller and x2 is simply x1 plus 16, right? So it's simply gonna be fx1 plus 16. So this is our first if condition. So if this condition happens to be true, we're gonna run another condition, and this time for the y. So if s head y is greater than fy and s head y is smaller than fy plus 16. In this case, we have a collision right here. Collision. So all we have to do is simply say s head. So take our head object dot restart, which is the function that we created right here. Missing two arguments. Yeah, because restart takes a screen width and a screen height. So the first condition, this condition is correct. So we're saying if the snake head is less than fx plus 16, so we're saying if this is less than this, then there is a collision, right? So if this is less than this, there is a collision. We also want to check if this point right here, this point, is greater than this point. Alright? So if the head plus 16 is greater than x1, which is this. The head plus 16 is greater than this point. So all we have to do is add a 16 here, a 16 down there too, for the same reason, and now the collision should be perfect. So let's run it. And as you can see, the collision seems to be alright. And we are working with something great. Alright, so this seems to be working just fine. Let's also try and respawn some food. Yeah? So find a respawn. Take the self. Alright, and we already created a spawn function before, right here. So all we should do here is just set the self dot position x equals to this right here, and self dot position y equals to this. So I already explained this one before. Let's also add a screen width and screen height. So it's just resetting the class variable self.position x and self.position y to any random value between 0 and the screen width minus 16 and 0 and the screen height minus 16. Let's also create a color variable. So self.red, which is going to be self.red, which is going to be any value between 0 and 255. Alright, so all we gotta say is import random and say it's equal to random dot random integer between 0 and 255. Now replace this by self.red. This is going to be our red value, and whenever we respawn our object, let's just reset this value to another random integer between 0 and 255. So now let's run the program, and we should get a wider range of red that is very dark or less intense. However, look, this didn't work simply because we didn't run this program, because we didn't run this function. So whenever we have a collision here, let's also run the function f.respawn, and it takes, I believe, a screen width and a screen height. Let's save it and run it again. So as you can see, the red is a little bit lighter this time, and okay, the snake head doesn't have to restart anyway, so it only has to restart when we're hitting the corners. So let's try and hit it. There you go, it restarted, and it also changed the color, which is it respawned to another location and it changed the color, which is exactly what we wanted. Let's say we start at 155 all the way to 255, because the higher the number, the brighter the red. There you go. Let's also change the range here with our respawn function, so that each time it respawns we get a light version of the red that we're looking for. So as you can see, in theory we should only get reds that are between 155 and 255, which are only very light reds. So we're not supposed to get any darker red anymore. In the next video we're gonna start working on the tails and make the snake increase its length each time it eats our little fruit. So that's it for today, and I'll see you in the next video.